Hello. In this tutorial, I'm going to show you how to set up a basic pawn using the plugin. If you've already purchased the asset, I would strongly recommend that you join the Discord server and also download the demo project, which is what I've opened right here. It contains an animated mannequin character which you can use, and also a documented movement component as well, which is this one here, with a lot of tutorial text and a blueprint example code. Definitely check that out. It's also what I'm gonna be using as a basis for future tutorials, but for this one that we're doing right now, you can use whichever project you want. Doesn't really matter. I'm gonna use this one though, just because I don't want to set up a new map. Make some room here though. Yeah, you might as well use an empty project. The only prerequisite really is that you have the general movement module installed and enabled. You can double check that by going to plugins and type in GMC into the search bar, and this should come up and it should be enabled. Yeah, I'm going to start out by making a new folder, and I'm going to call it basics, just for organization really. And the first thing I want you to understand is that you do not need this character class here anymore. The plugin makes it completely obsolete. I'm going to create one just for reference, so I can point out differences and stuff as we go along. But what you want to do is go to all classes down here and type in gen pawn. And this is the base class that you want to use for all your future pawns that you want to use a general movement component with. So select that, I'll call it hero. And if you open that up, immediately you can see that you have no C++ components baked in here. You are free to add and remove whatever you want. So I'm gonna add a regular capsule for now. Drag that onto the root, and make sure you select the right collision preset, pawn. I'm gonna make this a little bigger here, maybe 1940. And we're not gonna use a mesh for now, so make sure to unhide this in game so we can actually see where we are, and we also need a camera. There's a spring arm, and attach a camera to that. Move that up a little bit, and I'm also gonna make this longer here. And also check use pawn control rotation. Alright, so if we compare the setup to the default character, we can see that we have all these inherited C++ components in here that we can't change and can't get rid of. But a bigger problem is this character movement component here, which is not even a blueprintable type. So if I try to create a blueprint based on this, so if I search for character movement component here, it doesn't come up, you know, it's not an acceptable base class for blueprint. So if I want to extend this movement in blueprint, I have to put my code somewhere else. And most people put it in here, into the event graph of the character, which is bad not only from a design standpoint, because then you have something that's conceptually the same, like movement, spread out across two different classes, but it's also bad from a networking perspective, because all the replication, all the netcode is in here, and this movement component does not know about any of your code that goes in here. So everything, anything you add here won't be executed on the server, it won't be predicted, it won't have client replay, none of that. Yeah, this is just a very flawed setup from the get-go. But we'll talk more about this when we get to the networking part of the tutorial. The general movement component, on the other hand, doesn't have this problem. So if I search for gen movement here, it comes up as a base class for a blueprint. And you can see the inheritance hierarchy here. We have the replication component, which unsurprisingly takes care of all the networking stuff. Then we have the general movement component itself here, which inherits from this, so it has all the networking baked into it, but it does not have any movement physics by itself. So you would choose this if you want to make your own stuff. But we're going to use the organic movement component for now, which is very similar to the default character movement in terms of what it can do, but it's quite different in terms of how it's implemented and the interface that it exposes and so on. So select that, and I'm going to call it hero movement. And just like before, we can just add that here. I can type that. you know, we're free to add and remove movement components as we want, so that makes it a very flexible setup. If we want to exchange this later, we absolutely can. We have another movement component made. You can just plug that in here. Alright, now we gotta set up the input, and because I was using the example project, I already have these. So if you use your own project, you just have to copy this. It's pretty standard stuff. The names for these bindings, they come from the GenPawn class. So if we go here, select the topmost row, and we also have access mappings category here. And these IDs, they give the name that you have to use in your project settings here. So if you want to have this called something else, you would have to change the name in both places. But these names are pretty reasonable, I think, so I'm gonna leave it at that. And yeah, now we're almost ready to go. Just set up the game mode, edit this, and this default pawn class needs to be our hero class. And also, whenever you use the gen pawn, you also have to use a gen player controller with it. So usually this is just player controller, so select gen player controller. Alright, and now if we press play, we can start. So we got this collision shape here now that we can move around with, and I can move upstairs and is affected by gravity, everything you would expect, really. And in case you're wondering why this probably looks different from your collision shape, is that I added some code to make these lines more visible, because I was concerned with the quality loss from recording and the YouTube compression and all, that this wouldn't be very visible in the final upload, but you don't need to worry about that. Yeah. Something else it can do by default is move up and down. So if we go back to the project settings and add another axis mapping here and type move up here, and put this on E and the other one on Q, and then this needs to be negative. If we do that, we can then also move up and down with our collision shape here. Yeah, amazing. Now, I realize this might be a bit underwhelming up to this point, but to be fair, we haven't even started yet. We haven't even looked into the movement component itself, but already we have a much more flexible setup, something that's much easier to iterate on. For example, if I want to replace this root collision here, I can absolutely do so. If I'd rather have a box, I can do that. Just drag that on here, delete that, and I don't know why Unreal does this weird reordering here. I don't like that. But yeah, we got a box now. Make this bigger again, choose the right collision preset, and unhide this in game, and now we got a box collision. And it can still do all the same stuff that we could do before. You know, this is a very usable implementation of a box collision with character movement. You won't get stuck on any edges or something, you know, which is always a problem with those pointy shapes. Yeah, you could use this in a real game. We also got, what else have we got? Collision. We also got a sphere collision here, which is maybe not so interesting, but we also got this custom flat capsule that comes with the plugin. And this is a really great shape for animals, anything that has 4 legs rather than 2, anything that's horizontally oriented. Give that here the pawn collision preset and also unhide this. And yeah. As we can see, it can still do all the same stuff. Yeah, maybe a character that swims, as you probably have seen in the trailer. That is really useful. Alright, now with the basic setup out of the way here, we can finally take a look into the actual movement component. And I'm just gonna go back to a regular capsule for now. Yeah, that's the point where we had this capsule. Alright, and this is the movement component now. We are now in here, which we couldn't do previously with the character movement component, but we can do now. And what I have already got in here is just what I did to make this collision shape more visible. You don't need to worry about that. In fact, I'm just gonna hide that. Alright, and if you right click in here and type into the search bar general movement component, you can see all the functions and events and properties that it comes with. There are a lot. But what we want to do now is type in event movement update. That's the most important one, and also event bind replication data. Alright, and one thing I can't stress enough is that you need to call the parent implementation here. So click that, hook that up. In fact, it goes for any event that you use, unless you know that you don't need the parent implementation. For example, here I know for a fact that the parent is empty in this, so I don't need to call it. But if you don't know that and you don't consciously decide that you don't need it, that you don't want it, then always click this and just hook that up here. Alright, what we're gonna do now is set up our action mappings, our button input. If we go to project settings again and add an action mapping here, I'm gonna do a jump now. Sort of put that on spacebar. And one difference here is that if you're used to the event graph of the actor here, if I right click into this and type in jump, this comes up as an input action, and you probably used to putting your logic then here with pressed and released maybe. But this is not how it works in the movement component, for one thing, because you can't, it doesn't come up here, but also because that is not the right way to replicate it. It's very hard to replicate something like that. It's just a random event. What we want to do instead is go to the actor blueprint, select the topmost row here, and set your action mappings here as well. Similar to what we have done with the axis mappings. So this also needs to be jump. Alright, and now we have to bind this to an input flag. And we do this by bind input, calling bind input flag here, and also setting this to the to jump. This has to have the same name. So make sure it's the same name in all three places here. There are probably better ways to set this up. For example, in the construction script, you could probably grab the names from the project settings and put them in here automatically, so you don't have to be careful to synchronize everything all the time and then feed that as a variable in here. But we'll keep it simple for now. So what this does when you this takes in a boolean variable by reference that we need to add. So I'm gonna call this do jump, and we need to we need to put that in here. And what this does now is that whenever the user presses the jump button, in my case that's the spacebar, whenever the spacebar is pressed, this will be true. And whenever it's not pressed, it will be false. So don't write to this or anything, it's just meant to read the actual physical user input. And we can then use it in our movement update here. And this movement update is kind of like a tick function. It's usually called once a frame. You can use it like a tick function anyway. And yeah, this is the main event where you put your movement logic. So I'm gonna make a branch here, and I'm gonna copy this down here. It's nicer. Yeah, we can branch on this. So whenever what I want to do is whenever the user presses the jump button, I want to add velocity to our pawn in the upward direction. Maybe 10,000, that should be enough. And yeah, if we try this out now, whenever I press the spacebar, we kind of do this little jump upwards. And it's not a very great jump, I admit that, because when I hold this, it just goes up indefinitely. More like a thrust, really. Thrust upward. But we're not trying to win any prizes here. We just want to integrate some very basic logic, so I can show you how to set up input and also show off the networking. So next we're gonna do a crouch, I think. Bind input. Want this to be a crouch. So add the variable do crouch. Plug that in here. And so now we need to make sure that we actually have this crouch here in the axis mappings. I'll put it on left control and also in the hero blueprint here, crouch. Alright, and we can branch on this again. This goes here. Plug that in here. And the general movement component comes with a very handy function called lerp wood collision half height. What's our regular half height? I think 90. Yes, 90. Alright, then I think 60 would probably be a good crouched height. So while we press crouch, we want to interp towards this 60 value half height with an interp speed of 200 maybe, and when we release the button again, we want it to go back to normal, so this would be then 90. I'm gonna use move this, has to be down and up, I think. Yeah, I'm not gonna explain this now too much. Keep in mind that whenever you don't know what a function does, you can hover over it, and they are all documented, and also the input and output pins are all documented. You know. Just when you don't know how something works, that should be your first move. Alright, so we're gonna do that now, and we can see when I press Control, we kinda interp towards this contracted shape, and when I release the button, we're back to normal again. Now that's all well and good, but the real magic of the plugin kicks in when we go into multiplayer. So if I start up a listen server here with 2 players, everything we've done up to this point will just straight up work. No smoke and mirrors. This is actually already fully replicated with prediction, client replay, lag compensation, the whole shebang. Maybe make this a little bigger here. And also play with the server, you know. This just works. This is a fully server authoritative movement. I can prove that to you by taking the cube here and scaling that a bit. Make it more like a wall. And if I go here now and disable, where is it? Net load on client. This means this cube will now only exist on the server. So if I start that again. And this is the client. The other window in the editor is the server. We can see that on the client this wall is missing. If I try to go through that as a client, you know, the server won't let me. Probably go on top of it if I manage to do that. Yeah. You know, it's server authoritative. Now let's compare this to the default Unreal character. As we established previously, you can't put any code into this character movement component here from Blueprint. You can extend it in C++, of course. It provides an interface for that, but it's really not all that great in my opinion, and quite limited in what you can actually do with it. There are some tutorials on the web about that. If you're interested, you can take a look at those, but actually you really should take a look at those, because then you can come back and appreciate even more what this plugin is doing for you and how much easier it makes your life. But yeah, what I want to do now is kind of emulate what people usually do if they want to replicate their movement code that they've put into the event graph of the character here. So I'm going to reuse this jump event, and I'm just going to do something very simple for now. Just going to add an impulse to our character whenever I press jump. Maybe 1000, and velocity change should be fine. Try that out in standalone first, and this this works as expected. Now if we try this with a dedicated server, place client, this doesn't work. And those of you who know anything at all about replication might point out now that I also have to run this on the server, of course. So I'm going to do that. Custom event, gonna call it jump RPC. Run that on the server, even make it reliable, and call that here. And then we run the same logic on the server. Alright, if we play again as a client here, first glance this appears to work, you know. But we can make sure if we go to the console and type in p.net show corrections, This will show us any corrections that the server applies, and we can already see that something has happened there. We can take a look at the log here, and this also shows us that the server disagrees with the client. We can see that we have a location difference here, very small, but it's there. The server has corrected the client. And the reason why you don't notice that usually, why it appears to work, is of course latency. You may know this as your ping. Real networks have latency. Your packets that you send out from your computer to the server take a certain amount of time to get there, and also the packets that you receive back from the server also take a certain amount of time to get back to you. So real networks have latency, and by default, when you play in the editor, you have no latency, That's why it appears to work. It's just the corrections are just being applied too fast for you to notice, and it's too small. But we can actually exacerbate this issue by just introducing some fake lag, or simulating some lag in the editor. You can do this with this command here, net emulation.packet lag. That's in milliseconds. I'm gonna use 200, which is probably as bad as it gets in a real online game. And if we do that, now we are simulating 200 milliseconds of ping. And I try to do this again now. And see that we get a very bad lag here. This is really not playable at all. And yeah, this is actually the reason why you can't properly replicate your movement code in Blueprint. People write their whole games like that, only testing in the editor without ever introducing any lag into it, without ever testing in a real network environment, and it appears to work, but it actually doesn't. There's actually no way, when you use this character class here, to properly replicate your movement code. It's just impossible. It doesn't work. So we're back in our hero blueprint, and if you click on this hero movement here, you can take a look at all the parameters that the general movement component exposes. Some of these are pretty similar to the character movement, so you might recognize them, but you can explore this for yourself if you hover over any parameter here. They're all documented, and it's pretty self-explanatory. We also got this networking category here, and there are a lot of parameters to adjust as well, but most of them are complicated, so if you're just a beginner, you fare better with these presets. And up to now, we have been using this LAN preset because the editor has no latency by default, so this has been working pretty well. But now we have introduced 200 milliseconds of latency, and if we read the description for the low-end preset, it says up to 200 milliseconds latency is acceptable for this, so we're going to choose this now. And let's try that again with we're playing as a client with our hero actor, and we can still see that this works without any lag, without the lag that we experienced with the default character. Can make sure that we have 200 milliseconds of lag, and it also says this in the output log probably. Yeah, here net emulation.packet lag 200, so we actually have 200 milliseconds of latency here, but this still works without any problems at all. So yeah, in principle, it's really that easy to replicate your code using the general movement component. If you add additional data to your blueprint, which you will have to do at some point if you're doing anything of note, you will have to take care of that data. For example, if I add this float here, if I do anything with that in my code and it carries over its value, its state, to the next tick, I will have to tell the framework what to do with that. And I do this by using the appropriate binding function, similar to what we have done with the input flags here. So for float, I would use bind float. And then I would just feed that into here and tell the framework what to do with it by checking the appropriate boxes here. Yeah, that's something that you have to do still. But don't worry about it, it's not hard, and we're gonna go over this in detail in the next tutorial. It's just that we can't replicate everything to everyone. That would be a huge waste of bandwidth. So you still have to tell the framework what you want to do with your data. In case you're wondering about, and also the example project covers this topic, so take a look at that as well. If you're wondering about this replicate checkbox here, I haven't forgotten about that. We really didn't need this for what we did today. It's just that if you have more than one client connected and those other clients don't run any logic for your pawn on their machine, so if they should be aware of your input because it plays some animation or effect or something, then you would check this box, because they just interpolate the state that they receive from the server. So yeah, they don't know anything else about what you are doing in here. There's going to be a lot more tutorials in the future, and if you already own the plugin, please join the Discord server. The link is in the description as well. You can get support there, give feedback, make suggestions. You can also request specific tutorials, and maybe I'll do them. But yeah, that's it for now. See you later.